If you pretend all queries are English, search quality collapses as soon as you expand markets. We will wire up language detection and tokenization, so multilingual search stops being guesswork. You notice searches that work for English fail for other scripts. Results miss obvious matches, and users get frustrated. By the end, you will understand how to detect script, tokenize by language, and retrieve across Latin, Cyrillic, Arabic, and CJK. You will have a small Python pattern you can extend to real data without heavy libraries. I'm Professor Pi, teaching search and IR from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. Search systems fail at the tokenizer. Most simple pipelines split on spaces and lowercase text. That works for English and similar scripts. It fails for Chinese, Japanese, and other scripts where words are not space-separated. It also mixes scripts and noise when punctuation or directionality appears. The practical symptom is low recall and odd rankings when you expand to more users and languages. Language-aware tokenization fixes two things at once. First, it chooses token units that actually capture meaning in each script. Second, it lets you route or filter documents so matching is focused and fast. Intuitively, for Latin scripts, you want word tokens. For Chinese, you want character n-grams. For Arabic and Cyrillic, you often want word tokens with Unicode-aware splitting. The trade-off is precision versus recall. Larger n-grams can reduce false positives, but may miss short queries. We will build a tiny pipeline that shows the whole idea end-to-end. It detects script, tokenizes per language, ranks with simple term frequency scoring, and finally demonstrates language routing to narrow candidates. Think of it as a minimal, extendable baseline. Now we start with a failing naive search to motivate the rest. This snippet shows a naive whitespace search that fails on Chinese. We create 5 tiny docs spanning Latin, Cyrillic, Arabic, and CJK to mirror a multilingual corpus. The variable Q holds a Chinese query with a space between terms, which works for space-separated languages, but not CJK. The expression builds a set of whitespace tokens per document and checks whether any query token appears. Because Chinese words are not separated by spaces, the Chinese doc does not produce matching tokens. The printed empty result highlights how naive tokenization breaks recall beyond English and similar script. Next, we need to detect which language or script each document uses so we can pick the right tokenizer. This snippet tags each document by script to drive language-aware logic. The function lang inspects Unicode character names and maps CJK to ZH, Arabic to AR, Cyrillic to RU, and everything else to LAT. It concatenates names only for alphabetic characters, so punctuation does not confuse detection. We then build langs, a mapping from document ID to language tag, which we sort for deterministic output. This simple heuristic avoids heavy libraries while being robust enough for routing and tokenization decisions. The printed mapping confirms our multilingual mix and gives us a signal to branch on N. Next, we will tokenize each document according to its detected script, so that matching units align with queries. This snippet tokenizes by language, so CJK text becomes searchable. The function tok takes text and a language tag and returns character bigrams for ZH to capture words without spaces. For other scripts, it lowercases and extracts word tokens with a Unicode-aware regex, which handles Latin, Cyrillic, and Arabic. We then build index, mapping each document ID to its language-appropriate token list. If you increase the n-gram size for ZH, precision may improve, but recall can drop on short queries. The printed Chinese tokens show meaningful subword units that our naive approach missed. Now we will score documents by how many query tokens they contain, using the same tokenizer for the query. This snippet ranks documents with simple term frequency matching. We tokenize the query using the same language-aware tokenizer, ensuring the query and documents share comparable units. The dictionary scores counts occurrences of each query token in every document's token list. Sorting by score and then ID makes the top selection deterministic and easy to debug. This establishes a minimal cross-lingual retrieval baseline that works even for CJK, thanks to bigrams. The printed top IDs confirm the Chinese document bubbles to the top under language-aware tokens. Finally, we add routing logic to limit which documents we score against, which improves speed and precision. This snippet routes the query to same language candidates before scoring. We detect the query language with lang and build a candidate list canned by filtering docs that share the language tag. We then reuse the language-aware tokenizer and compute scores only within the filter pool, reducing noise and wasted work. Sorting produces a stable top list that is both faster and more precise in multilingual corpora. Increasing routing strictness reduces false positives, but risks missing cross-lingual matches. Relaxing it increases recall and latency. The printed route shows a tiny yet complete multi. Applied to a real project, this toy pipeline maps directly to production choices. A language detector becomes a fast pre-filter. The tokenizer becomes a pluggable component you can replace with a library for low latency. The scorer becomes the place to swap in BM25 or dense retrieval later. The core idea is the same. Match units that make sense for the script and avoid mixing incompatible token sets. Recap: it is language-aware tokenization for multilingual search. Use it when your corpus mixes scripts like Latin, Cyrillic, Arabic, and CJK. One caveat is that routing and n-gram sizes change the precision versus recall trade-off. Next step, tune the Chinese n-gram size and routing strictness to find the best balance of recall and precision for your dataset. If short practical IR helps, subscribe and watch the IR videos.